Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. Just a reminder before we get into topics that next week will be our last week of podcast for a while as we go on our summer break until we return on September 25th and 26th. Just a week's heads up on that. And with that said, let's jump into stuff here. So our first topic of the day is from Draft Security and is about Dependabot, which I haven't really used, but seems to be somewhat common in the dependency hell ecosystem. So Z, I'll let you get into this one.
Yeah, and I mean, if you've used GitHub very much, you've probably seen Dependabot around. Not so much something you use, but something that just kind of exists within the ecosystem, constantly scanning all the projects. And effectively what it's doing is it's just looking for, or it's looking at your dependencies, and it's like, are there any dependencies that need to be updated? Oh, there are. Let's just write that PR for you automatically, sends that to your project, and you can choose to accept it or not. Just kind of taking, or not necessarily taking away that headache, but at least acting as a prompt or a reminder to actually do those updates and keep things up to date, because that is kind of an issue with a lot of projects. So one thing that Dependabot does is it'll take a look, and if you set one for your dependencies, and they're specifically talking about doing this within the context of like a node application or something using npm. I'm not super familiar on the internals of. Well, I'm not familiar at all. Not just not super familiar with the internals of Dependabot. But I'm quite confident I've seen this pop up on things that weren't npm. But this vulnerability in particular is in dealing with npm based dependencies. So anyway, you can go ahead and point, or actually, I guess technically not npm-based dependencies. So where this vulnerability comes in, or where the issues kind of start, is with this feature of Dependabot, where it will look and see, oh, you have your dependency pinned to a specific Git repo. So use the example here of using like Git and then the GitHub URL and giving it the particular short commit hash at the end, saying like, hey, this is my dependency. And you might do this either if you have a private repository that you just want to use as your own dependency and you don't want to make it a package, or if the package has an update that you want that hasn't yet actually made it to the release version. You might pin yourself onto the actual repo. So what it's thinking of is that latter case where you're pinning yourself onto, or you're pinning your dependency to the repository because there are some unreleased changes. And so what Dependabot will do is it will look, hey, have these changes made it to the release version yet? And if it has, it'll actually give you an update that'll just push you back onto the release version of the package. And they have the example here where it gives the package JSON pull request, where it's replacing the React call to just the proper version once that commit actually made it in. So kind of useful, especially if that's like what you did. You just temporarily changed over to the repository for access to some of those unreleased changes, or some random bug fix, whatever reason it might be, and moves you back over. So the future makes sense. Nothing wrong there. The security implication is, how does it actually know that updates happen, that one, the code you want has actually landed in the package, and that the repository is even the right package, that you found the right package. And that's where they started looking at trying to create this Dependabot confusion. Confuse the bot, make it think a package is, or an update basically is correct when it's not. And that led them into basically, how does it actually figure all these things out, and how does it do these checks? What it seems like it's doing is it will take the package name or the repository name, and it'll use that as the basis for the package name. So it'll go take that repository name and it'll just check npm for a package of the same name. So that already sounds a little bit problematic. Just package of the same name. It's going to think it's the same package. But then you also have kind of the aspect of how does it check if the commit has made it in? And to do that, basically it's going to First of all, you've got in the package.json, you've got the repository URL, which gives you the package name or the repo name and the commit hash. So you're going to have those two parts that's in the basically not attacker controlled side of things. And then an attacker could go ahead and create a npm package, assuming one didn't already exist. This does have to be basically a private package or private repository, or a private repository. The attacker would create a package of the same name as whatever that repository was. And then that package references its own repository source. So wherever it's getting its source from, it has its own reference to that, which is what Dependabot takes a look at. So that's attacker controlled. Dependabot is going to go and it's going to look at the attacker controlled repository to see if it contains the commit that it got from the dependency or the package.json file. And so something they don't talk about in this post, and so I'm unsure about, is they craft like a case there, an exploit here, where their example is this giraffe utils has the master commit. And so it's pretty easy to create a repository where master is like will be a child of or equal to the current release version, which is something I forgot to mention a bit ago. How it kind of checks if the commit was in there is literally just taking what was the commit, looks at the release version, looks at the release repo from the package, looks at the package and its version or tag and its repo and just looks at, okay, this commit or this tag or whatever, does this contain whatever commit they're pinned to? If it does, then it does this update process. So coming back onto this, an attacker could create one that matches master because everybody's got, or most projects have a master or a main or whatever. So it's easy enough to create a branch where master is going to be part of it. That's fine. But what they don't talk about is if you want to exploit this on somebody that actually uses specific commits. They have the example here with using the React commit. They have the short commit hash. If you would need to guess that, because right now an attacker, if you want to abuse this, you would need to disclose the package name or the package name and the commit hash in some way in order to kind of reproduce this. So I don't know what the attack process would be if you do have to do that. They talk about I've been crafting the exploit. They talk about how you can do this with master and creating the branch there. So if somebody pins to master, fine, you can exploit that. I'm not sure how reasonable an exploit would be if you didn't have some sort of disclosure of the commit it was trying to get to. And I don't know what the stats would be on how common using master as your pin would be. I know the couple times I've done this, I've always gone to a specific commit and not master, but that could just be, my habit. I don't
especially
know.
when you factor in what the use case is, it wouldn't really make sense to use something like main or master for your identifier.
It would make sense if you're not intending this to ever be a package. So if you're doing this in the sense of, and that's where the most attacks would be, is you just have a Git repository you want to use as your dependency, not actually caring about any of this, and an attacker is just kind of preemptively creating a package or guessing a package name. And that's where, you would pin onto master or main because, it kind of makes sense. So like there are a lot of cases of that where you might need to guess some.
That's fair. I was mainly thinking of the first case, but yeah. Okay.
Yeah, and that's kind of the main case that I have used it with is just getting the unreleased feature. So going on to the commit hash makes sense for me. I don't know how common it is just to pin off to master versus a specific branch though, or like even a specific tag. Because while I could understand people pinning onto master, it would make a lot more sense when because this is an external dependency, to at least pin it onto a specific version tag. Just because, master can change pretty rapidly depending on development there. You don't want breaking changes. So pinning onto a specific version makes a good bit of sense to me.
Generally, you don't want to run on the bleeding edge for a dependency. It's generally not a great idea, but yeah.
Yeah, like I mean, when we're talking about internal tools, it is a little bit different because the development ecosystem is kind of constrained and contained.
Mhm.
But I could see it going both ways, and just I don't have the stats to back this up on either side. But it is a cool attack. Like I like this kind of attack approach. It does depend on somebody having this like in GitHub. Dependabot runs, they do the PR, and they just accept it kind of blindly without thinking about it. That said, Dependabot does kind of suffer from the. I think there's a proper name for this, but like just kind of that fatigue of always seeing them or having it come up quite a bit that you just kind of always accept it or never accept it. Some projects just ignore them or disable it for their project. But it does have that thing where I think some developers could absolutely just click through, oh, Dependabot, this must be okay, and not really thinking about is this supposed to be a public or a public package or not. So it's a cool attack. It does depend on that human element making that mistake and actually accepting the PR. But definitely a believable one.
Yeah.
And guessing package names doesn't it's guesswork, but especially a lot of internal tooling and stuff. If you're able to start leaking some of that, say on a bug bounty or whatever, or on a red team engagement, you tend to see some patterns in the naming, so things can become predictable. Doing it completely black box, maybe not, but I could definitely see some use cases for this sort of attack.
Yeah, and it's worth noting that they got a $2,500 bounty for this report as well, out of GitHub. So it's not too often we talk about topics that have bounties nowadays, but yeah, this one got one.
Well, this is the bug bounty episode, but yeah,
It is, but yeah, it's unfortunately we don't have as many bounties as we sometimes have had in the past. Just by the nature of the topics that we've been shifting to.
yeah, looking for more interesting exploits rather than just the biggest bounty.
Yeah. Continuing on these sort of non-standard bugs, out of Ophion Security, we have them talking about customer support portals that were built off of Zendesk. And they kind of go into two problems, which is lack of sanitization on placeholders and API misconfiguration. So by placeholder, what they mean here is when you're writing a template for a response or whatever for customer support, you can have placeholders that will autofill certain data, such as the customer's name, the ticket ID, whatever. And this can be a pretty interesting attack surface, and as such, they're generally sectioned off to only like privileged users and processes. So it's intended for like an agent to use in response, or for admin API endpoints and automated response events, things like that.
Well, so I don't believe they really even intend the agents to really be writing these templates. These templates are really, I think, intended to be like whoever's setting up Zendesk to basically use these templates and set it up, and then nobody else touches them because it's like for the automated messages and such. Rather than like text replacement, where it would be the agent kind of typing in the template to use.
Well, they do mention Zendesk has built-in placeholder support allowing for agents and automated mailers to autofill user info. So I assume it's also for agents, because I could see where that would provide value, where it's like, that way you don't have to worry about mistyping something or sending a ticket ID that's slightly incorrect, something like that.
Yeah, fair. Anyway.
But yeah, but the main point there is that it's intended for like, privileged users to use. So why is it being talked about here? Well, Zendesk has two APIs, a requests and a tickets API. The customer portal is typically supposed to use the requests API, which is like the less privileged API, whereas tickets is the admin API, which has access to these placeholders. The problem is where Zendesk, intends the customer portal to use the request API, a lot of portals that are built on top of Zendesk incorrectly use the tickets API. which, where it's effectively the admin API can use these placeholders. With that, an attacker can potentially exfil some sensitive information. For example, you could pass like the current user.email in a request to the tickets API endpoint and get the authenticated user's email. Or you can get a list of CC'd people on the ticket and then use that to get access to the user objects inside it, which could include some other fields such as notes or whatever. Getting into a specific case they looked at, again, circling back to GitHub, when they looked at GitHub's custom portal, they noticed that it was built off Zendesk and was using the tickets API. And since a bot was responsible for ultimately creating the ticket in Zendesk, they could exfil the bot's user info or exfil someone else's info by CCing them on the ticket. So it's kind of an interesting attack in how it works. How impactful this would be would depend on the application and what it's doing. I think in many cases it would ultimately be like a PII info leak type deal. But still, especially in certain cases, that can be pretty significant. So, one of those bugs we talked about where it is a bit more context specific how much it matters, but yeah, it could end up mattering a lot in some cases. And GitHub seems like it might be one of them. So.
Yeah, and this one kind of comes down to just the misuse of the API using the I forget which API was which now, but using the wrong
the
API.
tickets
Yeah.
instead of requests. Yeah.
Yeah, and honestly, that feels. I don't know the whole design of Zendesk's API, so I can't make definitive claims here, but it does feel a little bit like a poor design choice. Although requests and tickets, like, if I'm looking at an API, I don't know it, but I'm like, okay, I need to create a ticket. I'm going to look at that ticket's endpoint. That's going to make sense to me to use it. I'd hope they have it documented that you should be using requests if it's, user created data or something. But it is one of those cases where it feels like there could be some bad API design here, but yeah, I'd have to look at it a bit more deeply to really be conclusive on that. But yeah, I mean, ultimately it does come down to that, just using the wrong API. Which
I kind of get what you mean though. Like intuitively, when you think about it, it's like, yeah, I'm dealing with tickets. I'll use the tickets API. Like it sort of violates the law of least surprise in a sense, where it's like, oh, you're not supposed to use tickets. You're supposed to use this other one. But yeah, I won't really go too much further on that because, like you, I haven't really used Zendesk very much. So maybe they make that clear and indicated.
Yeah, it could be a documented thing, so I don't want to hit on Zendesk too much there. That said, this sort of bug and abusing those placeholders, can definitely appear in other places besides Zendesk. Zendesk just seemed to have kind of the right scenario to lead to this because of the fact they have like the two APIs that are apparently easy to mistakenly use. I thought it was interesting the kind of info that you can get out here. And yeah, I thought it was kind of fun that they use the CC, add a random user, and then you get access to all of the custom fields that are associated with them. Which you mentioned, like the billing information, personal information. They also mentioned that in some cases they were able to extract like agent internal notes, including plain text passwords that say the user might have provided or something, or just the support agent's work status and stuff. So definitely some interesting information being stored there. And yeah, that is going to be very context specific as to what you get. But the vulnerability, it's a fun issue to keep in mind. I think in terms of testing for it, you either kind of have to know the platform that's being used already so you can use specifically what they're going for, or you kind of hit this along with the same test you do for like server-side template injection. Depending on how you test for that, of course. I mean, you're probably not getting code execution, or you're hopefully not getting code execution and those sorts of injections here. But if you notice how it's processing the like double curly braces or something like that, like one of those key tokens, you might find your way into this sort of discovery of this sort of vulnerability.
For sure. Getting into some more complex issues. Next set of asset note, we have a IIS authorization bypass, and yeah, quite a complex blog post. Z got a better handle on this than I was able to get, so I'll let him jump into it here.
Yeah, and there's several bugs in this one, and it's a little bit hard to follow the post, but I don't really blame the author on this one. It's a little bit hard. Like the last chain, which we'll get to in this, basically involves exploiting 3 vulnerabilities in one request. So like they kind of have to jump around a little bit, and there's a little bit that just feels a bit unclear, or difficult to follow. So I'm not going to cover this directly in order, and I will also mention they go into a lot of like their process information, what they were looking for, how they kind of ended up looking at this, or whatever thing they ended up looking at, how they kind of thought through the process of getting there, what they were doing. So there's a lot of kind of background information that I am just going to skip over here. But first thing I'll mention is that there are the first auth bypass, and also I think one of the more interesting aspects to this was basically just in a random controller, they found this simulator controller, or device simulator controller, got to go with the long names. They had this controller, and effectively what it would do is it would take it had a preview action, and the preview action would take a preview path, which came just from the query string. And ultimately you would end up calling a server.execute using that path. Goes through a little bit of indirection to get there, but ultimately gets that path and calls server.execute. If you're unfamiliar with server.execute, you have similar functionality in a lot of web frameworks. This is also like server.transfer be the same thing, or similar thing. And the idea is to implement a sort of internal redirect within the framework. So you're processing one request, and then you decide, let's redirect everything so it actually deals with something else. The main thing there is this happens internally, so it doesn't issue like a 302 redirect or anything like that. It doesn't issue a header back and go through the whole HTTP request flow again. It just, if you give it the path, it's just going to look up that path and try and process it again, brand new, but not starting the new request. It's all happening internally. And that's kind of the key thing. And you have, like I said, you have similar things. They call out like the couple more common things in Java. You'll see a request dispatcher forward and include in some Java code bases. I'm not sure what framework that is specifically. Java servlet. So yeah, commonly seen, commonly used there. Key thing there is, since it's internal, it doesn't go through the web server again. So if you have any sort of authentication check, if you have anything going on there, it's not going to get checked. So anything at a higher level than the actual application's logic can be bypassed. So you generally shouldn't use these sort of request dispatchers. And I kind of generalize these as just being, you're dispatching a new request internally. You shouldn't use these with arbitrary paths, with user control paths. Generally, you want to see the uses of them be, a request comes in, it's like you finish that, and you want to reuse like the logic you have on a get page or something, to print out the results of some action or something like that. Then you redirect it and just pass it along that way, sending it to a fixed location rather than an arbitrary location. In this case, because it's arbitrary, they can provide any file they want. They can provide any handler they want and get the request redirected there. So that means any sort of file reads that would normally be blocked by the IIS web server, they can get access to, provided the application can serve it. So that does mean that in this case, their restriction there was there had to be a MIME type register for whatever the file type they were trying to access. They couldn't access the web.config file. What they could access, though, or what they did find access to, was a backups directory, which contained, zip file with the web.config file. So they were able to leak that. But yeah, it gives access to basically all sorts of file reads and just hitting other endpoints that maybe aren't directly accessible to you if there is any early stage authentication happening at the server. So that's the first auth bypass. And it's just something to keep in mind. Like I said, most frameworks have this. it is implemented at the framework level, so you do have to be familiar with whatever the web framework is being used. But it is something to keep in mind and something to audit and look for. Because those redirects, especially if they are happening dynamically, often can be abused in some way just because they do skip off layers. And a lot of applications these days do use those other layers to provide, authentication, to act as a web app firewall, to do whatever. So anyway, using this vulnerability and leaking the web config, they were able to hit a known vulnerability, a CV from 2019, and it was just in Telerik. It was an insecure deserialization. The requirement on that one was they had to know the keys, the encryption keys that come out of the web config. So by leaking that web config using this first vulnerability, they can then hit that known CV. So I'm not going to dive too far into that, but they did have another RC that they were trying to hit. That was another kind of, not so much insecure deserialization this time, but unsafe reflection. So they just found in, hunting, they found their reflection util.call method. So kind of suspicious that, you're getting this sort of arbitrary method call on some object. And what it had was basically this primitive that they could instantiate any object and call a method on that object, provided it was an instance method, and it took a string argument because they could only send in a string argument. Although the argument itself was also something they control, so they could basically call any method with a string argument, which is a fairly powerful primitive to have with this request. Their challenge with that one, so I'll also say that they did find kind of a controller, or not a controller, a class that they could use for that. This out of the Telerik web rad pivot, this filters persistence property had a setter function staff, which acts as an instance method, and that ultimately led to a binary formatter .deserialize. So kind of a classic sink for deserialization bugs. And thank you, Chad B. New, for the raid. For those of you just joining us, this is kind of our weekly podcast, so I try not, our security podcast, I try not to deviate from our normal discussion too much. But again, thank you for the raid. So coming back in on the bug here, this unsafe reflection gave them a pretty powerful primitive, and they did find a class target, like I said, the Telerik web UI class. Leads into a binary formatter deserialize. It's a classic sink when it comes to deserialization bugs, so nothing too surprising there, and they can get a call to it. The problem is that this page itself, hitting this endpoint, was authenticated. And I believe there must have been at least two sets of authentication checks. There must have been something at the IIS level, because they do use the original bug that we talked about at the start, where that device simulator bug. They do use that to take advantage of this. But then they needed another one because it also expected there to be an actual user associated with this web context, which is where the second auth bypass comes into play for this chain. And since it needed just any auth user, wasn't checking the privileges of the user, wasn't checking, a specific username, they just audited basically everywhere that the context was written, or that the user in the context was written to. And what they found was a part of the mailing list component. What they found in there was they had this feature to support kind of viewing in browser. You would, if you sent out your marketing email, you sometimes see at the bottom there, like, click here to view this in browser. And to support that, they had this, you could configure, was a configurable option, not necessarily on by default, but they can configure a rendering user. This user that would just be set if they're viewing an email, so it doesn't complain about being unauthenticated or whatever. They don't dive too deep into what exactly was happening, but basically this renderer user, the way this was implemented, rather than implementing that sort of user check at the level of the page request, and or at the controller or something like that. It was implemented as part of the actual like HTTP request pipeline. So a request comes in and eventually just hits this one function that looks for one of these looks for two arguments, these EC underscore message ID and EC underscore ID. Point of these messages is just saying, what email you're trying to access. So you did need to have a valid knowledge of what these parameters were. But basically, it would just look for those arguments. If they were there, it would give them this render a user. All they need to be was present anywhere in the request. Didn't matter if it was going towards if it was going towards the email page or not. If they were in the URL, it would load them. Which feels like a bit of a silly way. But anyway, now that we have all of these parts that I've talked through, they all kind of come together in one request that comes to the device simulator. So the first bug we talked about with server.execute comes into server.execute, and they use that to hit the unsafe, or they use the preview path from that to hit the unsafe reflection that we talked about as the, I guess that would have been the third bug that we talked about, to hit that bug. And then they also provide the URL parameters, these two, from the email or from the mailing list stuff, in order to have a user so that so the RC, or so the unsafe reflection actually lands. So 3 bugs, 1 request to land kind of their actual unauthenticated RCE here. So yeah, bit of a pain to kind of get through. Like I said, the post itself felt a little bit hard to follow, but it's just a hard to follow bug. Like there's so much going on here, with ultimately leading off with 3 bugs. And that's not even getting into, the actual crafted deserialization payload that they used with that unsafe reflection that was in use. So yeah, I mean, as a post, I'll also shout it out just as something maybe worth checking for a little bit of their process information. They go into a good bit of detail about what they're thinking as they go through here, and it kind of flows in terms of flows through their not necessarily their thought process, but kind of their methodology, a little bit of insight into methodology that can be useful to somebody if you're kind of looking at, I guess, kind of a code review aspect to it. So I don't see code review methodology talked about too often, so there were some interesting insights here. Nothing that's terribly novel or creative, like, doing the sync, going from sync to source or source to sync, things like that. So nothing too crazy, but it might be interesting to you.
Definitely requires some mental fortitude to follow the bug chain, though. It's a complex process involved there and a lot of jumping around.
Yeah, I do think it was made a little bit overcomplicated because they jump into like the other RC in the middle of it. The non-related deserialization. Yeah, they're both deserialization issues yet too, which then makes it hard to talk about. But yeah, on a whole, like, I think it's a cool bug. It's a cool chain. Just to see like all these different vulnerabilities all merging in on the one request.
It's something we haven't really seen before, or not that I can recall anyway. It's like to that degree at least. So
yeah, I'm not sure.
Pretty neat. Up next, we have PwnAssistant out of Altlam, I think is how you say it. I don't know. It's a bit of a tricky name.
I mentally say Eltam, but I'm not actually sure.
Yeah, okay, I'll go with Eltam. But yeah, so this is a pre-auth RCE and Home Assistant, which is an open source automation suite. Similar to something like WordPress, Home Assistant consists of like a core, which is then extended upon with integrations, some of which ship with the core and are common across most, if not all, deployments of Home Assistant. The integration of interest here is the HTTP integration, which allows other integrations to register HTTP endpoints. And this Home Assistant HTTP server will start up like an auth middleware for handling authentication for endpoints that need it. One of the components that exposes HTTP endpoints is the supervisor component, which they talk about in some detail towards the top of the post. Basically, what it's responsible for is managing backups. It'll also deal with like updating the operating system if it's running the Home Assistant operating system, as well as managing other add-ons and stuff like that. So yeah, it's kind of a nice goal to go for as an attacker. Getting into the issue, which unfortunately they don't really detail too well on this blog post, but they do link off to their GitHub advisory for. I'm just trying to find that. I meant to get that earlier and I forgot.
I've got it up here.
You have it up? Okay, cool. So yeah, so the bug they found is in the endpoint for the has.io integration, which is like the bridge between the home assistant and the operating system. It would register a handler for HTTP on this has.io or API has.io endpoint, and it would determine whether or not auth was required based on the path. They basically had like a regular expression check, which had a whitelist for accessing static files like the logo, icon, anything in the app directory, things like that. The problem is that their check for checking against path traversal also relied on like a regular expression, which wasn't entirely sufficient. You can see they try to prevent like a dot dot slash and dot slash from making it through, and also try URL decoding. The problem is you can bypass that by double URL encoding. So by passing something like %25-2e, that'll get decoded to %2e by the check, which when it gets decoded again after the check when it's used will resolve to a dot. Once you have that capability, bypassing the other regular expression is quite straightforward. You can simply pass a whitelisted word like app, and then path traverse out of it into the endpoint that you want to get resolved to. The way they take this to RCE is after they're able to access the privileged APIs on the supervisor, they can simply install like the SSH and web terminal add-on to get root code exec. Depending on the deployment, this might be isolated inside of like a Docker container, but you're running as root inside the container, and if protections are disabled, the Docker socket is mounted and whatnot, and typically it's not too hard to escape the container once you have that level of access. It's not really meant to be like a hard security boundary, so
Yeah, I mean, especially
it's something to consider, but it might not be too big of a deal.
well, I believe especially if you have the Docker socket, as long as Docker isn't running unprivileged, which you can do and should do, but a lot of people don't. Um, you should just be able to start a privileged Docker container, which then is root on the host through the Docker socket.
Yeah. So that's not really a huge barrier or anything like that. So yeah, it's kind of an interesting bug chain. It is dealing with an issue that's in an integration which isn't technically in the core. But again, with these types of applications, you want it to be featureful, and so a lot of these integrations will ship with most installations anyway. So in effect, you're still able to hit a fair amount of targets with a bug like this.
I believe they mentioned that this is like a default provided plugin, though.
I believe the Has.io is shipped with all installations. So
Yeah, like well, they did mention the one type of installation which doesn't have it, but that was like running it. I forget what the context was on that. One type of installation didn't come with it, but it didn't come with it. Like it didn't have plugin support at all. Basically, if you disabled plugins, you didn't get plugins. Makes sense. I will say, and I've said this before, let's not use regex for authentication.
Generally, red flag. Yeah.
Yeah, I mean, if you're going to, at least, keep it small, keep it easy. I mean, like, this isn't too bad to read, but I'd rather see multiple regex here that can then individually be audited for problems. But then the fact they're also relying on that for their directory traversal, like, I don't know, tossing regex in with anything security sensitive is always a red flag. It can be done securely, but you've got some challenges involved with it.
Yeah, it's very much like it indicates like, hey, we need a check. Just throw it in the regular expression. Let's not actually try to do like a proper handling of that check. Like it indicates kind of like a rush solution. So and that's why we see it so often when we cover these types of auth bypasses. All right, so out of Datadog Security Labs, we have a Linux kernel vulnerability in the OverlayFS file system, which can allow LPE to root. So this is a pretty fascinating one. It's rare that we have a kernel vuln on the binary, or the bounty episodes. It's quite common we have them on the binary ones. And the reason it's here this week is because this is more of a logical type issue and design flaw type problem, particularly when it comes to dealing with set UID binaries and user namespaces. So OverlayFS, a quick overview for those who aren't familiar with it, as it's not a super typical file system to use. The idea is you can have two layers that comprise a file system. You can have an upper layer and a lower layer. When you write a file into the overlay file system, those changes are only seen on the upper layer, which effectively allows any changes to files that exist on the lower layer to be masked in the upper layer, but still maintain their original content in the lower one. Similarly, you can delete files from the upper layer, but you can't truly delete files from the lower layer from the overlay file system. It'll just kind of obscure the file and hide it by making a whiteout file. So you can see why this might be useful for overlaying changes to files while keeping a backup of the original. And the way that's facilitated is somewhat simple. You have a directory that backs the upper layer, you have a directory that backs the lower layer, and the OverlayFS is the merged layer, so to speak. But it gets somewhat complicated when you consider set UID binaries and user namespaces. Because
just before you jump into that, we'll just toss in and mention that this is basically what Docker does when you have like a base image and then you want to create like a live image on top of it. Just to put into a more practical use case for this rather than just upper and lower directories and writing that out. The practical use case is something like Docker. You have a base image. You want to kind of create your running container on top of some base image, but you don't want anything you do in that container to actually impact that original base image, so you could use it elsewhere. So you would create an overlay on top of it.
Yeah, that's a good example to point to of why this works the way it does. So yeah, like I was saying, it gets complicated when you consider set UID binaries and user namespaces, because what happens if you modify or somehow trigger a copy up of a set UID binary from the lower layer into the upper layer? Well, it's effectively like it is going to copy it into the upper layer directory, which can be a problem, because if you can effectively use user namespaces to create a lower directory with fake root, create a set UID binary, and then set the upper directory to some world writable location like the temp folder, you can get your fake root created set UID binary copied outside of the namespace into the temp directory and treated as a real set UID binary, which, as you can imagine, is quite problematic because it allows immediate root privilege escalation. The way they fixed this issue was basically made it so the set UID UID has to have a mapping in the lower layer's namespace. So in this attack scenario, in the lower layer namespace, the root user would be mapped to the lower privileged user. It wouldn't be mapped as root. And so, with this fix in place, when it would try to copy up the set UID binary, it would fail that check and it wouldn't allow it to go through. So yeah, it's quite an interesting subversion of like abusing OverlayFS to subvert the user namespace containerization, I guess. Just kind of playing different subsystems against each other, I guess, is how I'd put this one. It's quite a fun vulnerability how it works. And yeah, it was just not really considering that edge case of having set UID binaries in separate namespaces through an overlay file system.
Yeah, I thought it was a really cool bug. They did have to use Fuse as the lower file system just so it had like a root owner, because the Fuse binary would be root and would be able to write that file out. But yeah, it's just not considering all the implications of namespaces, which really, since namespaces have been introduced, has been a common source of bugs.
It's always been a problem. Yep.
But I really like this bug just because it is a pretty logical thing. You have this functionality that lets you kind of write files elsewhere and like move them around a little bit, has that transparent file moving. So you have that sort of functionality. And then it's like, how do you abuse that? I honestly had never even thought about trying something like this. So I really like this one.
Yeah. And continuing the trend of topics we don't typically see on the Monday episodes, from PwnWin, we have a Parallels desktop VM escape via plist injection and a talk to.
Didn't we cover Parallels a couple weeks ago on the Bounty episode? Just
we might have.
We don't usually. I think we've seen something somewhere recently.
We've definitely covered Parallels a lot more on binary, though.
Oh, yeah.
But yeah, so part of this, at least, is coming out of Parallel support for shared applications, which essentially allows you to display an application on the host Mac dock and be able to use that to launch a given application in the guest from the dock or launchpad. To facilitate that, Parallels will monitor the guest and send these toolgate requests. Toolgate is like the the middleman, I guess, between the VM and the host. So these toolgate requests to the host, which driver will then process to create helper apps. As part of that toolgate request, various fields can be provided and ultimately end up being placed in the XML property list or plist. So of course, if you're parallels, you have to make sure that the data coming in is sanitized and can't just break out of the XML tag it's placed in, or it could allow plist injection. And while most of the fields were sanitized, there were two in particular that weren't, being the URL scheme and the file extensions, which the guest would pass to tell the host which types of files it can handle and such. So that allows you to break out of the XML and inject arbitrary properties. The one that's of interest here is the ls environment property, or launch services environment, which defines environment variables before launching an app. So that's a pretty critical thing to hit as an attacker. By just setting an attacker controlled dynamic library directory, you could do like a dynamic library hijack get code execution. Unfortunately, actually like exploiting this wasn't quite that simple, as you would still need to be able to write an arbitrary file to use for the dynamic library, and there's no files in the helper app that you control entirely. But this is where another Parallels feature comes into play, which is shared folders. As you can imagine by the name, it's for allowing the guest to tell the host to perform whatever operation it needs on a particular folder to effectively share it across the host and the guest. Again, this is pretty sensitive functionality. The hypervisor needs to ensure that any file paths that are accessed are inside of the share, including symlinks. And that's where the talk to is. It's the classic old story. You can race the check of the symlink with the use of it to escape the shared folder and write an arbitrary file on the host, which when you chain with the last bug, you could use to get code execution on the host. So yeah, the second issue, nothing too crazy there. It's one of the like billion of these we've seen on the show before. But the first issue with the property list injection is kind of what allows that less interesting issue to be useful. So it's a chain of both of them, and yeah, again, just lacking sanitization on that XML going in.
Yeah, nothing too special
crazy.
about the lack of sanitization there. But again, lately I've been trying to choose some of these applications more as, if you are doing the bug bounty hunting, you don't need to shy away from desktop applications or anything like this. Like, you can find these higher level issues. This is very reminiscent of bugs you would find on the web, or at least you would find on the web like 10 years ago when XML was more popular. But bugs you would find on the web, you find these same application issues in any type of application, including VM in this case. So that's more why I wanted to highlight this post on the podcast, was like, you find these issues there. It's worth being aware of it because people make the same mistakes they've always made in every type of application.
Yeah, it's easy to put things into buckets and be like, okay, for these desktop applications, I'm going to look for memory corruption type issues, but on the web, I'm going to look for the more web style. Like it's easy to do that kind of segregation, whereas like you're saying, it is possible to see these more logical type issues impact things like virtualizers. So yeah, it's a good reminder of that.
I'm glad to see more people writing up vulnerabilities like that, because it's illustrating the point. And I mean, we've seen some pretty silly desktop bugs.
Yeah. So yeah, I believe that's basically all the topics that we have. Unless you have any last minute thoughts, see, we'll wrap it up there.
Yeah, no shout outs.
All right, so as always, thank you everyone who tuned in. Previous episodes can be found on Twitch, YouTube, Spotify, Apple Podcasts, and more links off of Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat as well. We'll be back tomorrow at 7 p.m. Eastern, 4 p.m. Pacific for our binary episode, and we'll see you then.